My name is Alfredo Terrazas, and today's date is March 28, 2021. This is my submission for CIRC05 Attempt C. In this circuit, we use a chip, also known as an integrated circuit or shift register, to control 8 separate LEDs. We start with the source code. On top, we set up the variables data, clock, and latch with the integer data type and assign them to their respective pins on the Arduino. We then set up 3 more variables, on, off, and LED state, that will be used to manipulate the LEDs later on in the source code. We use the void setup code block only to set up the variables as outputs. Moving to the void loop code block, we start by setting up a delay time and a for loop to send the LED states to the chip on the breadboard, or the shift register, if you want to call it. Next we see the update LEDs command that is used to shift out 8 bits of data to the shift register, then displays the data on the LEDs by pulling the latch on the chip to high. After that, we have the update LEDs long command that is similar to the previous command, except it uses a for loop to repeat 8 times and uses a bit mask to shift out the 8th bit. It also uses the variable value to make the previous bit 7, to bit 8, so it can shift that bit out next, and uses that data to either set the data pin to high or low, depending on whether the 8th bit is set. 3 lines in this code block are used to pose the clock pin, as you will see shortly, and the last line of code is used to pull the latch high to shift out the data to the shift register, which is then displayed as data using the LEDs. Lines 75 and 76 are used to store the bits and bit masks. Lastly, we have a code block that clears the state of the bit that is being addressed and adds it to the LED state if it's on. Then we use the update LEDs to send the new LED state to the shift register. Moving to the Arduino, we can see the bits being shifted and displayed by the LEDs. You can also see the difference in bit rate by observing the rate at which the LEDs light up and the shift to the next LED in sequence. Using the shift register, we only have 3 data pins on the Arduino that connect all LEDs to the shift register through individual wires. We have these 3 that are connected to the shift register, and then each LED has its individual wire that's connected to that chip on the breadboard. All of these components are powered using the same 5-volt and ground pins on the Arduino, these 2 right here, and on the Arduino by using jumper cables accordingly, and all 8 LEDs have the respective ohm resistors to prevent burnout. Each one has its own ohm resistor. And again, you can see the different bit rate from each LED as it updates and shifts out to the next LED in the sequence until all of them have been set, at which point the void loop code block ends and repeats. Again, my name is Alfredo Terrazas, and this is my submission for CIRC05 Attempt C.